You know, in pretty much any large-scale cooling system, there's this hidden problem lurking. It's like a silent tax on your efficiency, and it could be costing you thousands, maybe even hundreds of thousands of dollars every single year. So what's really going on inside those chillers of yours?
Okay, so what if I told you that a tiny layer, just 1 millimeter thick, that's about the thickness of a credit card. What if that was coating the inside of your chiller's pipes? It seems like nothing, right? But what if that tiny layer was secretly just draining your budget?
Well, here it is. This is the bad guy, mineral scale. It's all that stuff like calcium and magnesium that's just naturally dissolved in the water. Over time, it just builds up. And this image, wow, it's a perfect and kind of scary look at what happens. Down below, you've got a clean pipe, but up top, that pipe is just choked with scale. It's literally like cholesterol hardening the arteries of your entire cooling system.
All right, let's talk numbers, because this isn't just a maintenance issue. This energy thief, it's got a very real and very high price tag. We're talking about a direct hit to your bottom line.
So here's how it all falls apart. It's like a domino effect. First up, that layer of scale. It just kills your heat transfer. We're talking a loss of up to 40%. So what happens next? Your chiller's compressor has to go into overdrive to make up for it, pushing its energy use up by 15, maybe even 30%. And it doesn't stop there. Those pipes are now narrower, right? So your pumps have to work way harder too, burning about 15% more energy just to push the water around. It's a total triple whammy on your energy bill.
Okay, so the most important thing to get here is that scale is basically insulation. Think about it. You want those chiller tubes to get heat out of your system, right? But scale does the exact opposite. It's like wrapping a blanket around them, trapping the heat in. And that forces the condenser to run at a higher pressure, which makes the compressor, and that's the biggest energy hog in your whole chiller, work way, way harder just to do the same job.
So for years, the go-to solution has been, well, just dump a bunch of chemicals in the water. But that whole approach, it comes with its own set of problems, costs, and risks. It's time to look at the old way versus a much, much smarter way. So the old way, it's this endless cycle, right? You're always buying chemicals, always adding them in. It's a never-ending operating cost. And here's the kicker. It's so easy to get it wrong. If you don't use enough, scale forms anyway. But if you use too much, you can actually cause corrosion and start eating away at the very pipes you're trying to protect. And that's not even mentioning the headache of dealing with environmental rules and getting rid of those chemicals.
So what if you could just fix the root cause of the problem for good? Not just slapping a temporary chemical Band-Aid on it, but a real one-time engineering fix that just changes the entire game.
And this is AE Flux. And check this out, it basically solves every single problem we just talked about with chemical dosing. It's a physical device, it's totally chemical-free, it uses zero electrical power, and once it's in, you don't have to do a thing to it. It is the definition of fit and forget.
So how does this thing actually work? This is where it gets super, super cool. The idea here isn't to take the minerals out of the water. Nope, it's to change their behavior, to change their very structure, so they just can't stick around and cause problems anymore.
It all happens in 4 simple steps. First, the device puts a very specific electromagnetic field on the pipe. As the water flows past, that field interacts with the mineral ions inside. This is the magic moment. It triggers a shift in their physical shape, how they're structured. And then, these new little microcrystals can't stick to surfaces, so they just get flushed right on through the system. Simple as that.
And this slide, this shows you exactly what's happening. It's perfect. See on the left? That's calcite. It's hard, it's spiky, it's sticky. This is the stuff that becomes scale. But A-flux forces those same minerals to form as aragonite instead. That's what you see on the right. They're soft, they're round, they don't stick to anything. They just stay in the water and get washed right out of the system. Problem solved.
I love this quote because it just nails it. Nothing is added or removed from the water. AE Flux modifies only mineral behavior. So you see, it's a physical process, not a chemical one. The water chemistry doesn't change one bit. The only thing that changes is the shape of the mineral crystals. And that makes all the difference. It stops them from being able to form that nasty efficiency-killing scale.
Okay, so that's the science. It sounds great in theory, right? But the real question is, does it actually work out in the field? Let's take a look at a case study of a commercial chiller system that was dealing with this exact headache. All right, here's our patient, a big 500-ton HVAC chiller system. And it was in a place with super hard water, meaning it was just loaded with minerals. And yeah, you guessed it, it was getting slammed with scale buildup.
The compressor was working harder and harder, and performance was just going down the drain. A textbook case, really.
And the results, I mean, just look at this. It's pretty amazing. On the left, those are the heat exchanger plates, just caked with thick, nasty scale. And on the right, that's the same equipment, just 6 weeks later. Clean. Get this, not only did it prevent new scale, it actually dissolved the old stuff and flushed it away. And the best part? The chiller never stopped running. No shutdowns, no taking it apart for cleaning, zero interruption to their operations.
And of course, the numbers absolutely back up what you see in the pictures. So the key number we're looking at is the condenser approach temperature. You can think of it like a report card for your chiller's efficiency. A lower number is an A+. Well, over 8 weeks, it dropped by 2.5 degrees Celsius. And that translates directly to a massive 18% improvement in the chiller's total energy efficiency.
So what does an 18% efficiency gain actually mean? What does it look like in real-world numbers? For this one chiller, it worked out to a savings of 280,000 kilowatt-hours a year. That is a huge amount of wasted energy and money that they're now getting back.
But wait, there's more. The savings didn't just stop at the compressor. Because the pipes were so much cleaner, the pumps didn't have to work as hard. They used about 15% less energy. The overall water flow in the system shot up by 22%. And maybe the best part for the maintenance crew, they were able to completely stop doing those quarterly chemical cleanings and all the downtime that came with them.
And the really powerful thing here is that these aren't just numbers from some random case study. You can apply this exact same thinking to your own systems and figure out what that hidden scale tax is really costing you.
The folks over at Advanced Engineers actually have this awesome online calculator. You can just pop in your own system's details, things like flow rate and how many hours it runs, and it will give you an instant estimate of your potential savings and how fast the payback would be. It's a fantastic little tool for turning this idea into a real plan.
So that really brings us back to the main question. That hidden tax on your chiller's efficiency? It's real, and it's costing you money every single hour your system is running. But the key takeaway here is, you don't have to keep paying it. So the only question left is, are you ready to find your hidden savings?